things got a little jumbled in here, so I'm going to sketch this once more, and let's see if we get a little light on the subject. Okay, now if we have a curve and a point on the curve represented by a vector r of t, then we can express that vector in terms of a unit vector in the direction of the radial line. That's u sub r, and that vector is I cosine theta plus j sine theta, and a vector u sub theta equals negative, we'll do that, negative I sine theta plus j cosine theta. If we take the derivative of ur with respect to t, then we're taking the derivative, I'm going to use the prime, I cosine theta plus j sine theta prime, and this is I times negative sine theta times d theta dt. Could have written that as theta prime. Prime does indicate derivative with respect to t. And that's then plus j times cosine theta d theta dt. Now I can factor out the d theta dt, and I end up with negative I sine theta plus j cosine theta d theta dt. Now, aside from the interpretation in terms of motion, the geometric interpretation, just a pure symbolic notation, we see that what we have here is just our u theta vector, so that this is u theta d theta dt. Similarly, if we do d of u theta dt, we get, now I'm not going to write out the u theta and the derivative, but we're going to end up with negative I cosine theta d theta dt plus j sine theta d theta dt, and that's j times negative sine theta d theta dt. And if I factor out the d theta dt, I end up with minus I cosine theta minus j sine theta times d theta dt, which is just, if you look at the ur vector, I cosine theta plus j sine theta, this is the negative of it, that's negative ur d theta dt.